Hello friends, today I'm going to talk about design patterns. We all use C++ and there are many times we have to implement a very flexible design so that that design incorporates all your features as well as future changes. We got to implement that design in such a way that you have a minimal code change uh, whenever there is a future requirement has been changed or additional features are incorporated are supposed to be added. In such situation we have to write our classes, our objects in such a way that the least code has to be changed. All this I'm talking about is about object creation. So when we talk about object creations, we got to focus on creational patterns. So creational patterns facilitate us the way we create objects, and these objects has to be uh, extensible. We have to make these classes extensible, scalable for the design aspects. So we have to remember two things here, that adhering to design principles, and secondly the most important thing that brings us to a very good design is flexibility or the loose coupling, right? So what does this loose coupling is all about? Loose coupling talks about implementing everything through interfaces. Once you implement your class design via interfaces, the your code is automatically loosely coupled with the consumer application, right? So the application which consumes your DLL is the one which talks to your functionality of class through an interface. There is a bridge. This part of exe knows three things: what to pass as parameter to the interface function, and what to expect as an output from the exe, from the DLL I mean, and how to call that function that is present into the DLL. These are three things that are being least considered or bothered by the application who is consuming your DLL. So I'll give an example of abstract factory and factory pattern. This comes under creational design pattern, and this creational design patterns always talks about how do we create objects, how the concretions of such objects happen. Okay, coming to the factory method. So what does factory method design pattern talks about? It says how do you create objects for several derived classes. So you have a shape class, for example, and from the shape there can be so many concretion. So shape becomes the abstract class which has no real objects, so no concretion at all. So all the classes which are derived from the top class, the base class which is shape here, rest of all those classes are the concretion of that shape, right? Same way, if we take example of employee class, there are two set of employees: confirmed employee and there is trainee employee. So these are the two concretion of the employee class. Same way, this class shape, which I am going to take as example, has three concretion, assuming that first one being the rectangle shape, second one being the triangle shape, third one being the square shape, right? Triangle, square, and a circle. Any of these, any shapes, there can be n number of concretion of the shape class, because there are hell lot of shapes available in this world. So we have to just consider two things here. We have to make a base class, and secondly we need to derive these three classes which I just told from the shape. And shape class, which is a base class, offers a static method. That static method is going to be a factory method which will eventually return the types of object you ask it to. Say you ask it, please give me triangle object. Say you say to that, please give me rectangle object, give me circle object. Once you pass input, once this function receives that input and it creates that particular object of that class which you requested and returns you that. And this returning thing can only happen if this function's return type is the base object, the shape. So if I say get shape being the function name, and it returns C shape pointer, and parameter section it takes enum shape type, E shape type, enum shape type, which has a variable parameter variable name E shape type. In the function body, what you write? If E shape type equal to rectangle, then you say return new of C rectangle, right? Else if shape type is equal to circle, then return new of circle. Under another else if shape type equal to square, return new of square. So basically this function is keep on returning the object that you are asking to it. And then you have a hierarchy of classes inherited from the shape, and the shape has two APIs. Let's say it has get area function, right? Or it has get detail function, that is being virtual function. So the virtual function enables you to implement dynamic polymorphism, and this dynamic polymorphism makes you to select the right version of the function accessible to the derived object, the most derived object. So when you have made this setup all done, and in main function you create shape class, you try call that get object, get shape object function by passing a type as, let's say you are trying to ask to get a rectangle object. So you write a statement like this: C shape scope resolution operator get shape object, in parameter you pass rectangle, since you are interested to get the rectangle object. The call went there, the same if else statement is present, there it returns you new rectangle, and that has come back to you. Now you store it into a shape object only, because base class pointer can point to derived objects. Here the derived object is a rectangle class object, so shape class pointer P shape is storing this object of rectangle being written from that factory method. Now this P shape calls the virtual function overridden by specifically by these classes. So the base had this get shape detail function, which was overridden by each subclasses. So these all subclasses have implemented the body of the shape super base shape function get shape detail as per their wish, as per their properties of the shapes basically. Hence now this execution which happening at the runtime makes the right version of the get shape detail function being called when your factory method is returning your rectangle object, then you are calling the rectangle class function overridden, basically overridden by this rectangle class. So this is a dynamic dispatch, also called as dynamic polymorphism of C++, and hence this becomes a factory method which is capable of returning the object of several derived classes from the base class, and thus your job is accomplished. What if tomorrow in future there is new types of shape come into market and you have to give implementation for that? So what is a minimal code change that is required is go to the shape, this base class function, the factory method, get shape function, write one more else if condition, if shape type equal to that new shape type, then return new of that shape type. Basically you have to inherit another class from this shape again, as like other rectangle, triangle and square have done. You create one more class inherited from this shape class and add this minimal code change into that factory method and make same set of call, shape class, scope resolution operator and get shape detail, which will return you eventually the type of object you requested to it. So it acts as a factory method. It acts as a factory of, it produces so many objects, so it acts as a factory. Since it's a method, we call it as factory method. Since abstraction is at the method level, everything is present at the method level, so we say it as factory method. So there is a similar implementation done in abstract factory design pattern as well. I'll come to that later. I'll make another separate video for that. There I'll explain how does it different and what is the level of abstraction that has been maintained over there. So this is all about factory method pattern, and I hope you like this video. If you like, please hit a like button and let me know in comment box if anything else I need to add up into this video, and you can subscribe to this channel if you wish to. Thank you so much for watching this video. This is Anup Kumar signing off. See you next time. Thank you so much.